All right, we will go ahead and get started. Welcome to CropProphet's August U.S. grain weather webinar. Thanks everyone for attending. Uh, First and foremost, we hope that you get some value out of the webinar and that you find the information helpful and useful. And so just to highlight, we've been highlighting it so far, but we do a Friday, Monday series in which we take a look at the forecast of the forecast. On Fridays, we give an outlook for what Monday's ECMWF 1 through 7 and 8 through 14 day forecast is going to be. In the past couple of weeks, we've had some really interesting results, and it might be that by the end of this presentation, hopefully you'll realize it might make sense to continue to watch those videos. You can look for us on YouTube by searching for CropProphet. We'd really appreciate if you followed the channel and tuned into these videos on Monday and Friday mornings. Probably everyone on the call is aware that yesterday the USDA released its WASDE corn and soybean yield estimates. It increased the corn yield estimate to 188.8 bushels per acre, an increase of 7.6 bushels per acre. It increased soybeans to 53.6 bushels per acre, an increase of 1.1 bushels per acre. And some of the important news was that the corn estimate included a modification to planted acres estimates that increased corn acres by 2 million bushels, 2 million acres, and it reduced the soybean planted acres by 2.5 million acres. The corn futures, as shown here yesterday, dropped precipitously. Soybeans increased undoubtedly because of the reduction in planted acres. The reason I show this is after the July webinar, we got a little feedback. We got a piece of feedback that someone asked, why don't we ever show the actual yield forecasts? So CropProphet is both a grain weather risk monitoring tool. It's also a weather-based grain yield forecasting tool. And we believe that the grain yield forecast component really is one of the key differentiators of the product. And while other companies will release their grain yield forecast publicly, we do not do that. We think our customers are buying the grain yield forecast, and there's no reason to give it out for free. It only degrades the value of the forecast. And so hopefully the customers that are on the call were not surprised by the USDA's estimate of 188.8 or the soybean estimate of 53.6. So just a little note there, but certainly this was big news yesterday. So let's take a look at what happened in terms of precipitation during July. I think the summary of it is it was wet. We see that Iowa was the second wettest July since 1981, the wettest being 1993. The U.S. national crop production weighted statistic for corn is basically 159% above normal precipitation, and soybeans was 148% above normal. So certainly a very wet July driving those corn yield estimates higher. Now, in the month to date for August, we do see the emergence of a dry pattern, primarily in the eastern corn belt. It's not dry everywhere, but certainly we see Illinois, Indiana, and east, and then south of those states emerging as a dry area. We'll talk a little bit more about this towards the end. And even if we go look at 90 days, so the core of the growing season, we see that production weighted corn and soybean precipitation was between 126 to 130% of normal, with really the only areas of concern there in Ohio, Indiana, and Western Michigan. And even those are relatively benign, drier than normal signals that emerge. Oops. And so one of the things to consider then is in our corn yield forecast model, we do have a drought predictor. And so far this year, the drought predictor is the single greatest contributor to the corn yields this year, which is to say the lack of drought is really helping to drive the forecast for yields in our model. And so, interestingly, if we zoom in on July and change from percent of normal to actual precipitation totals, we see counties, several counties in Iowa have between 10 to 15 inches of rain during the month. Quite a few, well, I'll say roughly the same number had between 8 to 10 inches. And so if we look at the change in the yield forecast for Iowa at the county level over the prior 4 weeks, we do see some declines in the yield forecast. And so while our yield model has multiple predictors, we were wondering whether the rainfall, the excess rainfall, may be impacting corn yields in Iowa. And so in the past, in earlier webinars, I've shown the season ending yield estimates versus different weather variables, usually temperature and rainfall. In this case, I'm showing the change in the CropProphet corn yield model for counties in Iowa versus the June through August 10th rainfall totals. And so we see some very large rainfall totals, greater than 20 inches over that period. And the model itself is actually responding to those the substantial rainfall by decreasing the yield. So our estimate is that there has been enough rain from June, primarily concentrated in July, that it is impacting yields in Iowa. So this is a case where we're starting to have too much rain. If we look at corn production weighted statistic over the prior 90 days, we see nothing but green. To highlight this, the gray envelope in the top chart, that gray band in the middle, that is the 90th percentile envelope. So 90% of prior years from 1981 will fall within that gray envelope. And what we see is so far this year, after the prior 90 days, we're actually just outside that envelope. So I've been telling prospects and customers sort of that's it's an easy indicator of when there is an extreme event occurring. The further outside the gray envelope you go, the more extreme the event is. So we're right on the cusp of what I would say, for purposes of discussion, an extreme precipitation event for the United States corn crop. And if we look at soybeans, it's a very similar story. Looks essentially the same. The numbers are slightly different, but we're at the upper end of the 90% envelope for precipitation. If we take a look at the I states, we see, no surprise, Iowa, in fact, is reaching well above that 90% envelope. So it has an almost 7% inch surplus, and almost 20 inches of total precipitation over the prior 90 days. Illinois is above normal, but not in the extreme category, and Indiana over the prior 90 days is just above normal. But surpluses across the board in each of the I states. And again, certainly supporting the development of positive corn and soybean yields in this case. And just to sort of drive the picture home, we calculated state, in this case, corn production weighted precipitation, ranked them from 1981. And so, as I mentioned, Iowa is number 2. We see Illinois is number 2, Nebraska number 3, Minnesota number 4. All of these states are in the top 10 of precipitation. So again, it's been wet. And the result then is the drought categories are decreasing substantially. The corn production weighted drought index is not quite at 0, but it's darn close. We'll see what happens here with the potential emergence of dry conditions, whether it actually reaches no drought conditions across the Corn Belt. And the soybean chart also looks very similar in this case. And then we also see relatively small percentages of the severe drought categories. For corn, that 0.6 and 0.3%, they're in the western states. Again, the core of the Corn Belt and the core of the soybean belt has essentially no drought risk. If we take a look at temperatures, we see a pretty stark contrast aligned with the Mississippi River. Warmer than normal temperatures east of the Mississippi, and then slightly warmer to below normal temperatures west of the Mississippi during the month of July. The story of the summer, if precip isn't one, is certainly the daily minimum temperatures during the month of July, and in particular during the soaking period. And so again, we see the same contrast that generally east of the Mississippi, we see quite high daily minimum temperatures, and west of the Mississippi was generally not a problem. And so we can also look at the rankings here. So in terms of July corn production weighted daily minimum temperatures averaged over the month of July, we see Ohio, Indiana, Illinois, and Wisconsin are 1, 2, 3, and 4. And then you go to the other side of the Mississippi River, and while it's in the upper end of the distribution, it's certainly not near record categories. So if we look then, so far August has generally been cooler than normal, and there's been no real temperature risk so far yet in August. We can also then look at the same type of chart, and the highlight here then is if we look at Iowa, Illinois, and Indiana minimum temperatures, we do see there are days when the daily minimum temperature exceeded my threshold for an extreme event. So it's outside of this 90th percentile window. And we actually see that in both Indiana and Illinois, there's probably a combined 8 to 10 days of greater than that 90th percentile. We certainly expect variations throughout the crop season. And we see that certainly variations occurred, but minimum temperature is definitely a story to talk about. And so to talk about that story, we did an analysis of the temperatures during the corn silking phase for Iowa, Illinois, and Indiana. We compared years from 1981 to 2024. So those are each of the dots on this chart. The y-axis is the corn yield deviation in percentage terms from the technology trend, and the x-axis is the deviation from normal. What I see out of this chart then is that on the left-hand side, we're looking at the average corn silking maximum temperature. The right-hand side is minimum temperatures during the corn silking period. And I see a slight difference in these two charts. And so on the maximum temperature side, high temperatures during the corn silking phase is going to generate yield declines. On the right-hand side, the minimum temperature chart, we see that high minimum temperatures can generate yield declines, but it doesn't necessarily cause that. So there are other factors combined with minimum temperatures that will result in yield declines. And then the green lines are this year. So what happened during the silking period during 2025? Again, we see Iowa maximum temperatures very near normal. The two other states, nothing extreme. Whereas for Illinois and Indiana, we definitely see that the values were extreme, and that's supported by the fact that the rankings were number 2 and number 3 most highest minimum periods during the month of July. So again, I think my assessment would be that the high minimum temperatures almost certainly impacted yield, but not to a disastrous level. And so it probably ameliorated the potential for an even higher crop yield during 2025 at this stage. So in the July webinar, we talked about the North Pacific mode. And so the Northeast Pacific mode is a sea surface temperature pattern that when it's positive, sea surface temperatures in the Gulf of Alaska are warmer than normal. It influences the circulation pattern over the Midwest. What we've seen is since 2012, basically, the temperatures have really been very moderate during the silking period of the corn crop. And so we've added 2025 this year. So again, we see from 1981 through 2012, or even 2014 here, we see substantial variation from year to year in the daily average temperature during the silking phase. And then the key, what we talked about in July, is the NPM has generally been positive during July since, say, 2014. And we believe that is having, it's reducing the volatility of temperatures. It's preventing extreme temperatures. And in fact, this year, the daily maximum temperature for the U.S. corn crop was essentially normal during the silking period. So the NPM ameliorated the heat risk again. On July 25th, I was in Illinois and I presented some content similar to this presentation, but the day's session ended with a group of producers from all around the Midwest talking about their crop so far this year, sort of what they've experienced and what they're expecting for the crop to be. And almost all of them said they're expecting a really big crop unless the winds come. And so, in fact, the winds have come. And so we are looking at the Storm Prediction Center's wind reports. And so there was a wind event on July 28th and 29th. The size of the blue dot indicates the wind speed, and obviously the location of the blue dot indicates where it occurred. So we do see some substantial wind speeds across key corn growing regions of the Midwest. And so I want to compare and contrast this. If recall the derecho during 2020, that derecho had small areas where wind speeds were estimated to be above 120 miles per hour and larger areas above 100 miles an hour. We see on this chart wind speeds, reaching 90 or 75 miles per hour. And so the damage to the corn crop is going to be exponential to wind speed. And so while 90 miles an hour is not fun and undoubtedly caused damage, it wasn't a catastrophic type damage like we experienced in 2020. And so the other aspect of these high wind speeds is they are very localized. And so while, again, very localized crops, corn or soybean may have been impacted, it doesn't reach to the status of impacting the crop at the national level. There was also a secondary event that occurred around August 7th to the 9th. So again, there's wind events. In the end, there's probably, if we went back and looked at the data, we'll find there's wind events that occur every year. And those wind events in the end get factored into the yield estimates. If there was substantial damage due to severe wind or due to hail, it would eventually show up in the crop condition reports. And so the state level crop condition reports from a historical perspective for 2025 so far this year show that Iowa is now at the highest we've seen since 2000. And soybeans at 96th percentile is probably the second highest seen. And so what we see in these charts of the relative rankings of the crop condition reports, again, is generally west of the Mississippi. We see positive, relatively high crop condition reports. East of the Mississippi, we see some difficult conditions for sure. For corn, likely related to the high daily minimum temperatures. And whereas, say, Iowa has just consistently had rain, the eastern corn belt has not consistently had rain quite the same way that the western corn belt has. So again, crop condition reports are generally quite high. The national percentile of 82 for soybeans and 88 for corn is, as the numbers imply, quite high relative to the maximum possible, which would be 100. So if we take a look at the change in the forecast, we did a webinar around this time in July. And so we can look at the 4-week change as an indicator of the change in the yield forecast since that webinar. The 2-week change would obviously be the change in the yield forecast from approximately 2 weeks ago. And we see that a majority of the change in the crop yield forecast occurred in the first 2 weeks of the period. And one thing I do notice is there's only, in the corn yield change, there's only one state that went from green to yellow or brown, and that is Illinois. So the minimum temperatures are undoubtedly impacting Illinois for sure. And then in soybeans, we also see a similar pattern of decreasing corn yields as we head to the southeastern portions of the crop yields, or of the crop growing regions. Let's take a look at the weather forecast. So we're going to look at the ECMWF from this morning. In the 0Z forecast, the 1 to 7 day forecast for precipitation does show large areas of dry conditions across significant portions of the corn and the soybean growing regions. And the result is essentially 75% of normal precipitation. In the 8 to 14 day time frame, we see a continued dryness. That contrasts with the temperature precipitation, in which the temperature forecast is for a warm period here over the next week, and then it's going to ameliorate, and the forecast is for normal to below normal temperatures across the significant growing regions. As we mentioned in the past, we can take a look at the performance. So again, in July, we looked at these results. So the green column indicates the model, ECMWF, GEFS, or GFS. The model that ranked first is green. The model that ranked second is white, and the model that ranked third is red in terms of the forecast area, the forecast error over the averaging periods indicated by the rolling period column. And so in July, the GEFS was generally ranked number one for several of the temperature categories. The world has righted itself, and the ECMWF has generally been the most accurate over each of the forecast timeframes over the different averaging periods shown here. And then if we look at the precipitation across the bottom row, we see generally that the ECMWF, in the 6 to 10 day range, there's a few averaging periods where it's been accurate, but the accuracy evaluation in terms of which model is first and therefore most accurate is a bit more scattered compared to the temperature. We can also take a look at how the AIFS is doing. So the AIFS is the ECMWF's new ensemble artificial intelligence-based forecast model. It was released earlier this year, and certainly we've integrated it into the products, and we're tracking how well it's performing. And the message hasn't changed much from the July analysis, in which the AIFS is slightly cooler relative to other models, and generally too dry relative to the observed conditions that is occurring. And so finally, let's take a look at the weather forecast impact on yield forecast. So again, we can take our yield model, which is a yield forecast based on weather conditions up to yesterday, and then we can tack on the weather forecast information and do an analysis of what the weather forecast implies for changes in the yield forecast. To reiterate, we run the yield model through each ensemble member. So the ECMWF is a 51-member ensemble, and the result is we get 51 possible yield forecast changes, and we present then the average of those changes as the national change. So the ECMWF implies that the corn yield forecast may actually decrease by 1 bushel per acre over the next 2 weeks, and likewise the soybean forecast may decline by 0.3 bushels per acre over the next week. And the reason is, as we'll talk about, is the shift from a pretty wet pattern to drier conditions. So let's take a look at the long lead. In this case, for the long lead forecast, we're going to consider an analog. And so if we take a look at several seasonal forecast models forecast for the Pacific decadal oscillation and the Nino 3-4 anomaly, both are in the negative territory. So the Pacific decadal oscillation is a North Pacific sea surface temperature distinct from the Northeast Pacific mode, but it also has a strong influence on North American climate. And then the Nino 3-4 anomaly is essentially an indicator of ENSO, so El Nino, La Nina. So this would indicate the potential for La Nina style influences during September and October over the United States. And if we combine these two together and look at what has happened to conditions in the past, we see several years end up being selected. So the years listed here are the years in which September and October had negative PDO and negative ENSO anomaly, so to be clear. And the result then is that September and October, on average, tend to be drier than normal. So the question, I'm sure in everyone's mind, is, are we going to have a year like last year in which September and October ended up being quite dry, and almost certainly impacted corn yields by the time the crop was harvested. So this simple analysis would suggest there certainly is a possibility that dry conditions may emerge here as we round out and end the corn and soybean season. And just to drive that point home, it is interesting to note that if we look at the prior 4 years, so 21, 22, 23, and 24, uh, it has generally been drier than normal during September. Uh, and again, this is not an analog analysis. This is just what happened over the prior 4 years. So if you want to take a persistence forecast for September, a persistence forecast would suggest drier than normal as well. And so that's the presentation for today. Today we will enable a question and answer period. There should be a question section in your Zoom interface. You can put your questions there, and we'll do our best to try to answer them. So there is a question about humidity going forward. And I'll say I actually don't have that answer right off the top of my head. What I will do is the person that asked it, I'll send you an email with certainly with the forecast information for humidity. There is a question about if we use satellite data to help with our weather calculations. So within CropProphet, we do include NDVI and VHI, Vegetative Health Index data. It is there as an analytical tool to try to understand the health of the crop relative to prior years, but it is not an input into our crop modeling process. We believe that it doesn't make sense to insert data in between what the crop is actually responding to, which is the weather data. I don't see, let's see. Here we go. So there is a question, do we update our area for the FSA estimates? So the way our yield model works is there's actually two independent models. One is a yield per harvested acre model, and there is a yield per planted acre model. And so we are modeling both independently based on the weather conditions. And in this case, when there is a change in the acreage estimate, we change the acreage estimate that we then apply to the yield per planted acre model, and that changes the overall uh, production estimate. And so if you happen to log into CropProphet today, you would see that there would be a change, a pretty substantial change in the production estimate because of the change in the acreage estimate. Great. So there is another question. I'm going to take a guess. So the question is, have I ever heard of tip back where the corn ear does not completely fill out? And so actually I have not heard of that but before. And the suggestion is that it isn't based on the warm temperatures. My answer to that type of question is going to be if there is a systematic impact that weather has on the yield, our model should capture it. And so the answer is probably yes. Well, that's all the questions. Thanks again for everyone who listened in. Thanks to everyone who asked questions. Again, I hope that you guys and I hope everyone attending gets value from the information that we are providing. Please reach out if you have additional questions, and we will schedule one final webinar for mid-September. Talk to you then. Thanks.